Hello friends, in this today's lecture we are going to learn about the pinout of 8085. As by learning the features of 8085 we learn that the 8085 IC is available in 40 pin DIP package, that is dual in package nature. CMOS technology is used to build this IC. So these 40 pins are arranged. The actual IC is not look like this. It is square one having 10 pins on each side. This this is symbolic diagram of IC which carrying 20 pins on each side. So here we are learning this 40 pin one by one. You have to draw this pin scheme on your notebook. Very important. The question is asked for 4 marks to draw this pin scheme. So first two pins, as you see, there are X1 and X2. These pins are crystals attached with them to input the clock to the processor. So again, in the last lecture we learned the feature that the clock frequency of microprocessor 8085 is 3 to 5 megahertz. So either it is 3 megahertz or it is 5 megahertz, and for that purpose here we are providing clock between two pins, pin number 1 and pin number 2, with double the frequency as it is get divided between the two pins. So in actual the crystal frequency connected is 6 to 10 megahertz. The next is reset out. This reset out is used for output message showing that processor is reset, so that its registers become 0, stack pointer, program counter, that becomes 0, and it can be reset for the next operation. Next pin is pin number 4, SOD, which stands for serial output data. So it is used to output data serially on port. Fifth one is SID. So it is input pin, serial input data, to input the data serially. Next 4 pin are very important, pin number 6, 7, 8 and 9, which are hardware interrupt that we learn in next one. So what is interrupt that we learn in the 11th standard? Interrupt is something which is occurred to change the path of execution and bring it again in the main path after the execution of the side job. So these 4 pins 6, 7, 8 and 9 belongs to the hardware interrupts of 8085. They are known as trap, RST 7.5, RST 6.5, RST 5.5 respectively, out of which trap is a non-maskable hardware interrupt and other 3 are maskable. Then pin number 10 is an interrupt pin showing that microprocessor is get interrupt. Then pin number 11 is INTA bar. You are seeing that line is drawn on that pin. So that line indicates that bar means it is active low pin. That is, normally other pins are active when they get signal 1, while these such pins are acting, which are having bar sign on them, active when they get signal 0. So INTA is the interrupt acknowledged. That is, it is output pin showing that interrupt is acknowledged by the processor. From pin number 12 to pin number 19, these 8 pins, you see that there are 2 letters A and D, AD0, AD1, AD2, AD3, AD4, AD5, AD6, AD7. So these are address data bus. That is, they can be used for data, 8-bit data, or they can be used for a purpose of 16-bit address. So here LSB of address can be stored or 8-bit data can be stored, depend upon the pin ALE that we will see next. So these are address data multiplex pin. Then last pin in the section is pin number 20, VSS, voltage saturation supply, which is used to ground the connection, providing ground connection from the supply. Now pin number 21 to 28, actually in diagram it is written as V8, but actually it is A8, the pin A8 to A15, which are at 8 MSB addresses. So the total 6 address of 8085 is 16 bit. So LSB is given from pin 12 to 19, whereas MSB are put on 21 to 28. So these are MSB of the address buses. Then pin number 29 is S0, which is a status signal pin which works with S1 pin number 33 and IO/M bar pin 34 pin. Okay, so they create the status so that memory or input output can be read or write. Okay, then next pin is very important pin, ALE pin number 30, which is known as address latch enable. This pin decides either AD0 to AD7 pins are used for address or for data. If that pin gets signals 1, then pin number 12 to 19 has address, and if that ALE pin has 0, then pin number 12 to 19 shows data. Next two pins 31 and 32 are WR bar and RD bar. Again they are active low pin. WR bar for write control and RD bar for read control, so that buses are tri-stated for the same function for input output devices. Pin number 33, that is S1 status signal that we learned earlier, and pin number 34, again an important pin which decides the strategy for input output. IO means input output and memory section. So M is barred, that is when signal is 1 to this pin number 34, it is used for input output devices, and signal is 0 to this pin, then it is used for memory. Next is pin number 35, ready pin, which is showing that microprocessor is ready to accept the input or produce the output on the input output devices. Okay, pin number 36 is reset in bar. This reset in bar pin is used, again it is active low pin, which is showing that it is the input signal for microprocessor, showing that it should be get resetted. Then pin number 37 is clock out pin. Clock out is an output clock provided to peripheral devices from the processor, so that they may get synchronized with the processor input output. Then pin number 38 is HLDA, which hold acknowledge, that is pin number 39, which is hold, that is processor is holding means it is giving that direct memory access channel to buses to make free flow of data on data buses. So hold and then hold acknowledge, which is providing to peripheral devices that processor is using DMA. And last one is pin 40, which is VCC, which is provided with plus 5 volt supply. So you have to draw this pin out in your notebook and write all these pins. See this description. I will send you the detail of every pin afterward. Thank you.